Welcome to Pigeon Lighthouse, where history and enchantment intertwine. In this video series, we will embark on a journey to understand and marvel at the engineering genius of the Fresnel Lens. Fresnel lenses are a masterpiece of craftsmanship that capture and focus light with unparalleled efficiency. Their brilliance at lighthouses like Pigeon illuminated the darkest of nights and saved countless lives. Join us as we step into the world of lighthouse optics at Pigeon and uncover the captivating secrets behind these beacons of hope.
My name is Richard Rue, and I'm a docent here at Pigeon Point Lighthouse. And today I'd like to talk a little bit about light and light control, why and how it's used. Most of us are fortunate to have two eyes that we can use to see with. And so we can use light to find out a lot about our environment, seeing where we are and what's happening. But we can also use light to add new information to us. Sometimes we can use it for things like reading, or we could use it for things like signaling. There's a lot of different signal lights that we see out there. Stop lights on cars that tell us to stay away, open or house lights that tell us to come. Traffic lights sometimes say stop, sometimes say come. So we use light for signaling. Okay, so now we want to ask, hey, we're at a lighthouse. Why would we have a lighthouse? Why is somebody going to go to the expense of making a lighthouse? And it's about signals, stopping, telling ships to stay away. Just like the brake lights on our car, it's a brake light for Pigeon Point. Stay away from Pigeon Point. Shipwrecks were common in the early 1800s. In the early 1800s, shipping was the internet of today. It was the way things got around communication. And so there was at least a shipwreck a day in the early 1800s, and they wanted to do something about that. And so what they did was put up lighthouses to stop it. The lighthouse says, keep away, it's danger. But we also should just recognize that early on, the first lighthouses that they built in ancient times, they had lights that said, welcome, come here. Pigeon Point is a stay-away lighthouse. The goal of a lighthouse is to send as much light as possible, and we'll use this to be like a ship, okay? We've got a light source that's radiating light in all directions, up and down. What we're going to look at here is like a 2D slice through the light source. So we're looking at it up and down, radiating, trying to go out to the ship. We'd like to get as much light out there as possible. How are we going to control the light? Well, one of the tricks we can think about or use is, I don't know if people have seen the broken pencil illusion, but what happens is when light enters or exits a transparent medium, it's going to bend, okay? And we can make use of this bending to control the light and make it go where we'd like it to go. Okay, so we learned, or we can see with our own eyes, we don't need to write any equations, we can just figure it out that if we have light going through a transparent medium, we can get it to bend. I've got something that looks like a window right here. It's flat on the front and flat on the back, two parallel sides. And you can see how the light bends when it enters the surface and then unbends when it comes out the back. So that's an important property, light bending when it goes in and out of a transparent medium. If I shape my medium well, people may have seen something like this, like a lens. I can get a lot more light going to the ship. Here it is without, here it is with. Okay. So I can use the light to control, I can use the lens to control the light. But one thing you'll notice is that there's a lot of light up above and a lot of light down below that I'm missing. The lens isn't getting it. If I try to move the lens up there, the light doesn't hit the ship. It's not going in the direction I want. What I need is something to bend these rays in a very strong way to come out. What you could use, and what they did use initially, was something like a mirror. You could use a mirror. A mirror will take those and bend those rays to come down and reach the ship. But in the early 1800s, all they had for reflectors was silver, something like the silver coin in a quarter, okay? That's not very reflective, and you're burning a dirty light source, kerosene or oil. Every day you've got to clean it. So that becomes a problem. So what Fresnel did, or what the trick Fresnel used, was he found out how to make glass act like a mirror. So we'll just show you, first of all, a simple case with a prism. So a prism is a shape, a solid shape. Oftentimes it has triangular surfaces on both sides. If I turn my light source around so I've only got a single beam coming out, it's a little bit easier to see. If I do my numbers right, if I do my geometry right, I can get this transparent surface to act just like a mirror. And I've got a transparent surface, it's made out of glass, I can clean the glass every day, and it's 100% reflective. It's a very good reflector. So what Fresnel did was, he said, okay, I'm going to use a lens in the middle, like a magnifying glass, to get the middle rays, but the upper rays, I'm going to use prisms to get those upper and lower rays to do that. Now, it may look like we're getting a lot of light out of the middle right here, but when you think about a globe and you think about the center of the North Pole area, this is just the center section right here. Really, that's only 15% of the light. The rest of the light is all above and below. So if you want to be efficient, you got to have something like a lens, like a prism using, acting like a reflector. The second trick Fresnel used was, he said, hey, look, remember when we had the window, the light only bent going in and out of the surface. So all I really need to do is pay attention to the front and the back surfaces. And I can cut all of the glass or material out of the middle. And so what Fresnel did was he made something, my light's bent a little bit, but he made something that acts just like that lens, but it's only by doing the front and the back surface that he gets a much thinner section. And so the two tricks we have that Fresnel used were using prisms to act like mirrors and taking down the weight of that center section to make a much thinner lens.